Okay, we have looked at multiplying polynomials, and now let's look at the opposite of multiplying, which we refer to as demultiplying. No, we'll probably call it factoring. That's typically the name for it, but it's really the opposite of multiplying. When you multiply, you take, well, here's our things. We're factoring polynomials with common and with grouping. When we are looking for multiplying, we take two numbers like 2 times 6 and we come up with a product. So 2 times 6, the product of that is 12. But I could go backwards and say, well, what makes up 12? And it turns out that 2 times 6 makes up 12, or I could write 12 as 3 times 4. Those are two factors of 12. For 15, I could similarly go 3 times 5. 3x, what would the factors of that be? I guess I can't really break that up, but I could say that 3 is a factor and x is a factor. If I multiply those two together, I do get 3x. Which brings me to the first kind of factoring, is how could I take this um, expression here and make it into something of, I have something times by something else. That's what I'm looking for, and that's what factors are. They're taking a product and they're breaking it down or re-expressing it as a product of two factors. Like we did with 12, we broke it down to 3 times 4. We want to do that same thing with expressions. So the first kind of factoring that we'll look at is something called a common factor. And I guess this is a process that helps us factor something. So what we do is we look at any expression and look to see if there's a common number that will divide evenly into both terms of that expression. You're already probably thinking 2, and that's correct. And what you do then is you write 2 out here by itself, and then in brackets, you write down what's left over when you divide each of these terms by 2. So 2x divided by 2 would simply be an x. 8 divided by 2 would be a 4. And we'll continue the plus in there. So here I have two factors of 2x plus 8. In other words, I have two things, a 2 and an x plus 4, that when you multiply them together, they give you this. Here's another one. Is there something that's common between these two? Well, it looks like 4 will divide evenly into both of those. And then the x's look awful suspicious too. Here I have 7, here I have 4. So really when you're looking at exponents, what you do is you just, it's like a subtracting game. So here I'm going to say that I'm going to have, this one's got 4, this one's got 7. So at most I could take out x to the 4th. Now I'll write what I get left when I divide each of these terms by 4x to the 4th. 4 divided 4 is 1. X to the 7th divide x to the 4th would be x cubed. So that's the first term taken care of. Minus, if I divide this by 4, I get 3. And if I go x to the 4th divided by x to the 4th, anything divided by itself is 1. So this would be 3 times 1, or simply 3. Again, I've got here now, I've got two things, two expressions that when I multiply them together, they give me this product. I guess actually here I could say I have 3 because I have 4 times x to the 4th times x cubed minus 3. Each of these three things would be called factors of this polynomial here. Here's a little bit longer one. I look and I see what can divide into each one of these evenly. A common factor. Looks like 3 is. Typically, if the first term is negative, we factor out a negative as well. Interesting thing when you factor out a negative is that it'll change the sign of each of the things in brackets. So negative 3x squared divided by negative 3 will be a positive x squared. 21x divided by negative 3 would be a negative 7x. Negative 15 divided by negative 3 would be a positive 5. Take a look at those signs and make sure you're feeling comfy there. Try some questions on your own. Hit pause. Try some on your own. When you're ready, hit play again, and we'll continue with the next section. Okay, here's just a quick application of that, and you could, if you wanted to, just do this one to prove to yourself that it's true. Here I have a function that defines throwing a ball. And so if I look at it, I have h of t is equal to minus 16t squared plus 64t. Well, I could rewrite that because 16t will divide into both of these. So I'm going to divide out a minus 16t. If I do that into here, I'm just left with a t. Divide this by a minus, it'd be a minus 4. Okay, so here's one expression. Here's the same expression, just rewritten. Notice that these all are factors of the original expression. Now, just to test to see whether this is true or not, they say at the back here, determine what the value of the function it is when you plug in a 2 for t. So let's try that here. So it'd be minus 16, 2 squared, plus 64 times 2. I'm just going to squeeze this in here. 2 squared is 4. 4 times minus 16 is minus 64. 64 times 2 is 128. Minus 64 plus 128 is a positive 64. Okay, now if I've factored correctly, I better get the same number. Let's just continue down here. So minus 16 times 2 times 2 minus 4. Interesting. So minus 16 times 2 is a minus 32. 2 take away 4 is a minus 2. Minus 32 times minus 2 gives me a positive 64. Hey, that's what we got originally. That's a nice way to check to see whether you factored something correctly or not. Simply plug in any number. Plug it in here, see what you get. Plug it in here, see what you get. If these two numbers jive, you're on the right track. You can try some questions if you like. The next thing that we'll look at is something called group factoring. And this is one where if you have a polynomial that has 4 terms, group factoring, there's a chance that you might be able to group factor. You can't group factor all 4-term polynomials. You can't. But some of them, we contrive them so that you can. And hopefully these two will work. What you do with group factoring is you just first factor the first 2 terms and then factor the last 2 terms. Then once you have done that, see if there's a common term that is left. In this first one, I can factor out a 3 and an x squared, leaving me with x plus 2. In the second one, it doesn't appear to be anything that I could factor out. When we do group factoring, we always have to group factor something out. So to factor something out of here that will not make a difference will be I can factor out a 1, because 1 times anything won't change it. But now when I look at this expression, I see here I have a term and here I have a term. In each of those I have an x plus 2. So I can rewrite this as just write 1x plus 2 out front and then write what's left over when I get rid of the 3x plus 2's. So I'd be left with 3x squared plus 1. So here would be 2 factors that when you multiply them together, you'd come up with this. And if you want, might be a good idea to check that out. So try and multiply. Use FOIL and multiply them all out and see if you come up with that. Here's another example of group factoring. Let's try it. 4 terms, so it might work. Let's try it. Out of the first 2, I can only maybe factor out a y squared, leaving me with 5y plus 2. Out of the second one, there's a minus out there that gives me a little bit of grief, but it looks like I can take a 2 out. So let's take a minus 2 out. Careful there. If I divide this by minus 2, I get a 5y. If I divide minus 4 by minus 2, I get a plus 2. Now take a look. Here's a term and here's a term. Each of them have 5y plus 2's. I can write that at the start and then write down what I have left over. So these two are factors of the original. Okay, one thing that you can do to check your factors. Thanks, Caitlin. My daughter giving me mail. One thing you can do to check your factors is you can graph them. So graph this and then graph this. And if they line up perfectly on the graph, then you know pretty well that you have factored it correctly. So there's an introduction to a little bit of factoring, group factoring and common factors, two useful tools to help us factor. We have lots more factoring in store for you, but that gives you a start. Try some questions, give us a holler.